Alright, functions class, here's the lesson we went through today on Friday, April 9th. So we are going to talk about how to solve, and we're going to talk about how solving with logarithms and some different steps that we can take. So one of the steps that we can take is we're going to write these down right here. So step one is we're going to transform the equation so that we only have one single log on one side, and then we're going to use the rule, or we can use the rules, the product rule or the quotient rule, and combine this so that we only have one. So what that means is we want something to look like, and it might not look exactly like this, but we want it to look like, you know, log base 2 of 8 equals 3, and we can rewrite that. We know how to rewrite that as 2 to the 3 equals 8, and then we can solve. So we're going to use that idea in a general sense. We also can use that if we have log base b is equal to x, and log base b of x is equal to log base b of y, then we know that x is equal to y, then we can use that idea to solve, or we can use it as an exponent. Either way, it doesn't matter, we're just going to do that. So that's what those two steps say all together, is that we're going to rewrite, we're going to condense, and we're going to try to get things so that we can start isolating and solving. Alright, so our first example is going to be log base 3 of x plus 1 to the 5th power is equal to 3. So we have one log already right here, so that means that we can rewrite that. So we can rewrite that as, well, my base is 3, my power is 3, and that is all going to equal x plus 1 to the 5th power. Okay, so then we have x plus 1 to the 5th power is equal to 3 to the 3rd power. 3 to the 3rd power is 27. We know how to undo a 5th power by using the 5th root. So if we take the 5th root of both sides, we end up with, so remember the 5th root, they undo each other, breaks them out of jail. So then we're left with x plus 1 is equal to the 5th root of 27. This is saying the exact solution, so that means we're going to leave that 5th root of 27 alone. I don't know what the 5th root of 27 is, some decimal, we're just going to leave it. So then we're going to subtract 1 from both sides, and that is our final answer. We can always check our solution and make sure it works, and it does. Alright, so now we're going to do this one. This is where we're going to condense our logs so that we can have 1 on both sides. So if we have addition right here, then we're actually going to rewrite that as multiplication. That's one of those properties that we know. So we know how to condense. So when we condense that, we get x log base 8 is equal to, log base 8 of 3 times 2x plus 5 is equal to log base 8 of 33. So for the purposes of this problem, I would say wait to distribute this until you are in the solving stage, because there might be a reason not to. So we end up with, so the logs cancel out, and we end up with 3 times 2x plus 5 is equal to 33. Here's one of those instances where it makes sense not to distribute, because we can actually divide by 3 here, and we can do that here, and we end up with a simpler problem. We end up with 2x plus 5 is equal to 11. Then we can subtract 5 from both sides and divide by 2, and we end up with x is equal to 3. Again, we can check our answer, plug it all in, and it is true. We can put that in our calculator. Alright, so, and by calculator I mean plug in what we solve for. So if we plug in a 3 for x. Okay, so, So now this is our next example. This is another one where we're going to condense. So we have subtraction. So this means this is my numerator, this is my numerator, this is my denominator. So I'm going to rewrite that as log base 3. There's my numerator, there's my denominator, and that's my power, because a logarithm always equals a power, and that stays the same. Now this is a lot like that first problem we just did. We have one log, so I can rewrite this as my base is 3 to the second power, negative second power, is equal to this answer, just like that. And since I know that, and I know how to deal that, I know how to evaluate 3 to the negative second power, that means I have to do, so 3 to the second power is equal to 1 over 3 squared, which is 1 over 9. So then I get 1 over 9 is equal to that. So I can start getting things by themselves. So I have an x in both the denominator and the numerator, so I need to get that out. So I'm going to multiply both sides by 9, get rid of that one, and multiply this by 9, and that's 9 over 1. So then I end up with, I get 1 is equal to 18x over 3x plus 15. So then I want to get rid of this denominator, so I'm going to multiply both sides by 3x plus 15. It's a 15, believe it or not. Here we go. 15. Those cancel out, but I've got to do that on this side. So 3x plus 15. 3x plus 15 times 1 is equal to 3x plus 15. So I end up with 3x plus 15 is equal to 18x. Then I can just start moving things. So I can move the 3x. And I get 15 is equal to 15x, which is 1 is equal to x. So not so bad, is it? So my solution is definitely 1. All right, so that was my last example that I did today. If you have any questions, please let me know. I hope you all have a great weekend, and have a great weekend.